So now this is the experimental setup for experiment E, which is related to the strain gauge measurements. You can see that you have three setups on this experimental setup, or three installations on this experimental setup. The first one is related to measure the tension. Okay? And the second one is related to measure the torsion. Okay? And the third one is related to measure the bending. And our experiment will be on this part, to measure the bending along this beam. Okay? You can see that this is just the shape of the strain gauges installed on our beam. This is the shape of the strain gauges connected to our beam. Okay? Either this one or this one, but this case is related to the tension. However, for our case of the bending beam, we have only one shape, which is this shape. Okay? So we have two strain gauges connected on the top side and another two strain gauges connected on the bottom side. These are the two strain gauges connected on the top side. As you can see. And the other two are connected on the back side, in another two colors, which are the yellow and green. So you can see that you have four colors, red and blue, and on the other side you have green and yellow. This is the digital reading box on which we are going to read the measurements for the voltage and the strain. You can see that you have the four dummy resistances. Okay, for the Wheatstone bridge. You have one knob which is related to the configuration. So if you are connecting to full configuration, it means four strain gauges are connected. If you have half configuration, either half opposite or half adjacent, then two strain gauges are connected. If you have the quarter configuration, it means that only one strain gauge is connected. Okay? This knob is related to the gauge factor, and you can see that the gauge factor for this experiment, it is written over here. Maybe you will not be able to see that it is 2.11. That's why it is adjusted here at 2.1, so we are not going to change this one. And this is the zero reset for the setup. So before starting each configuration, two adjacent or two opposite, or full bridge or full configuration, we need each time to press the zero reset. As you can see now that in our configuration we did not apply any load. However, we can read some strains and some voltages. The strain in microstrain and the voltage in microvolt. Microstrain and microvolt. Okay? So what I need to do, I need to press reset to make sure that both become zero. Zero and zero. Okay? What is this? This number is showing me the number of strain gauges connected. So however, this one is at 1, it's reading 2. It was reading 2, but now it's reading 1, which means that this knob is somehow losing. And it is a source of an error in this experiment. And this is the gauge factor, which we said it is 2.1 or 2.11. Okay? So let us start our experiment. But before starting our experiment, how we are going to apply the loads? This is a carrier to the weights. Okay? This carrier weighs itself 10 gram. So once I connect it to my beam, I slide it along my beam. Okay? I'll find that there is a scale along my beam. Fix it over here. So I need to fix this one at 400. Then I need to install these weights. Each weight of these ones weighs 10 gram. So once I slide it, I fix it over there. I enter it over there. It will go down and it will be sitting at the bottom. So now I'm applying 20 grams. 10 gram for the carrier and 10 gram for the weight itself. Okay? So when you read the procedure for the experiment, you will see that we need to fix the arrangement at 4 different arrangements, starting by the quarter, moving to the half opposite, to the half adjacent, and the full. And in each one of these, we need to apply different loads, different masses, starting by 50 till 500. Moving step by 50 by step of 50 grams. So I will apply 50 grams, then I will increase to 100, 150, 200, 250, 300, 350, 400, 450, and 500. Then I'll go down to 50, I will increase to 500, I will go down to 50, moving from the quarter to the half adjacent, half opposite, and the full bridge. And in each one of these cases, I'm going to measure the strain and measure the volt. I'm going to measure the strain and I'm going to measure the volt. Okay? Actually, in this experiment, we need to take care about different points. The first one, when I'm going to press 0 reset, to reset the digital readings before starting the configuration, before starting the reading from different configurations, I need to take care that the beam is free without any weights. The beam should be free without any weights. So after removing all the weights, now I can press reset. Now I can press 0 reset. So this is the first point. This is the first point. The second point when I'm talking about the configurations or the arrangements, as we said, we have four arrangements. The first one is only quarter arrangements. So I'm going to replace one of these dummy resistances with a resistance that's coming from the strain gauge. The second one is half adjacent. So I'm going to replace these two dummy resistances. Okay. The third one is half opposite. So I'm going to replace these two. I'm going to replace these two resistances. And the last one is full bridge or full arrangement. It means that I'm going to replace all of these four with the resistances coming from the four strain gauges fixed along the beam. Fixed on the beam. Okay? So this is the second comment. What about the third comment? The third comment, if I adjusted one spring or one resistance, it means that I have only one strain gauge that is connected. So I need to be sure that this is 1 and this number as well is reading 1. This number as well is reading 1 or 1, 2, no problem. Okay? If I fix it 2, I need to make sure to switch this one to be 2. Once it's 2 now, you can see that it's still 1. I told you that there is a problem. It is now somehow losing. So if I adjust it, it's now 4. I need to make sure that it is 2. Okay, now it's 2. I need to make sure that this number is 2. If I switch it to 4, I need to make sure that it is reading now 4. Okay? So these are 3 comments that are very important. 3 comments that are very important. I'm ready to the experiment. Okay? We are going to take 10 readings starting from 50 to 500. The first one, I will put the carrier and another 4 coins, which are the first 4. Then I'll add 5 by 5 to switch from 50 to 100 after adding this one to the remaining coins or to the other coins. Then 150, 200, 250, 300, 350, 400, 450, and 500. So the coins now are ready. So in order to make it easy for me to add 5 by 5 quickly after adding the first 4. So let us start the experiment. I have opened now an Excel file in order to save the data. So this is the mass in grams starting from 50 up to 500. It is a mass. Then these are the arrangements. So arrangement, the first one is quarter, the second one half adjacent, the third one half opposite, the last one is full. So, and these are the readings, the strain in microstrain, the voltage in microvolt, and the same for the other 3 arrangements. Okay, I'm going to fill this table. In your report, you need to draw the graphs using the LabVIEW. So you need to rewrite these data again in the LabVIEW, either by writing the data to a file and reread the file, or using the arrays, which will be more easier to you. After that, you will be connecting these arrays to the graphs to draw the curves either in one graph or different graphs. Okay, so let us start with the first arrangement, which will be the quarter arrangement. So for the quarter arrangement, you can see now that we have replaced the dummy resistance with one resistance that is coming from the red color strain gauge. Okay, I have adjusted the knob to be at 1. So it's now reading 1, 2. It's now reading 1, 2, the actual value for the number of strain gauges connected. It means that there is one strain gauge connected. The last thing that's still remaining, that without any load on the beam, I need to press reset. So it will be 0 values. It will be 0 values and start load the weights on my beam. Now I have fixed the carrier to my beam. I have fixed it at a scale of 400. I have fixed it at scale of 400. Okay, at scale exactly of 400. Added 4 weights, each one is of 10 gram and the carrier is 10 gram. Then I have now the starting value, which is 50 gram. Mass equals to 50 gram. Now what I need to do, I need to read the value for the microstrain and the microvolt, which you can see the microstrain is around 4 or 3 and the microvolt is around 10 or 11. Okay, so what I will do now, I will read 3 microstrain and 10 microvolt. Adding now the next 5, so I'm going to the mass of 100 grams and I want to read the values. You can see that the value of the microstrain is around 16, and the microvolt is around 45, 16 and 45. Or I can say 16 and 44, no, 17 and 45, 17 and 45. After finishing the 50 grams, 100 grams, we will go with the same way, step 50, 150, 200, till reaching the 500, as you can see in front of you, and we'll fill the table like this way. So I'll have the microstrains and its corresponding microvolt for the quarter arrangement. Now I need to repeat the same for the half adjacent, the half opposite, and the full arrangement, In order not to waste time, I'll be starting for the half adjacent from the 500 readings. Then I remove 50 by 50 till reaching 50, and I'll go with the opposite side for the half opposite. Then I'll go back with the full arrangement. So how we are going to make the configuration, the half opposite, or sorry, the half adjacent, how we are going to do the configuration, let us see. For the half adjacent, I have connected to the red one and the yellow one adjacent to each other. Okay, I have adjusted the knob to be at 2, and I'm sure now that it's reading 2. Can I press reset? I need to look at the weights. Are there any weights connected to the beam? Let us see. Yes, still the weights are connected to the beam. Then I need to remove all of these weights. Then I will go back. I can see that there are some residuals. So what I'm going to do, just press reset. So it's now 0. And I'll be starting from 500 and go back to 50, reading the voltage and reading the strain exactly like the previous case. Let us do that. Going back step by step to 50, we have decreased the load from 500 to 50 by step 50, and reading the voltage and strain for each time. So you can see this for the last reading, the strain is around 16 and the voltage is around 85. Microvolt and microstrain. Okay? So now I need to switch to the next, which is the half opposite. Before that, I need to remove the weight. Totally. Then I'll unfix this one. I will refix back the dummy resistance to be connected, and I will replace this one with the resistance coming from the strain gauge. Then it will be connected now. Then now I have 2 resistances opposite. Okay, so it is now half opposite, and I can see now that the configuration is adjusted at 2 connected, so no problem with this. The remaining thing that I need to do is just to press reset, 0 reset. So it's now 0. So what I'm going to do, again add the loads 50 till 500, step 50, and read the values for the strain and the values for the volt till reaching the 500. Then I'll go back with the full arrangement. Now I'm done with the measurements of the half opposite. I have started from 50 up to 500. Now I need to adjust the full arrangement and start the measurements from the 500 back to the 50 for the strain and the voltage. This is now the digital display. You can see the 4 strain gauges are connected. Now the value for the configuration is 42, which means it's connected to 4, which means 4 resistances are connected. Also, I did not press reset yet, so now I need to press reset in order to reset the values for the strain and the voltage and start the measurements from 500 gram mass. Then I'll decrease by step -50 till reaching the 50 gram to read the values for the strain and the voltage. Okay. With these readings now for the quarter, for the half adjacent, for the half opposite and full, we are done with this experiment. So now you need to go with the requirements and answer the questions. Now you need to take care about the objectives of this experiment. There are 2 main objectives for this experiment. The first one is to verify the values that you are getting for the quarter arrangement by comparing the values of the strain with the theoretical calculated strain based on the applied masses. Okay. The second one, to compare between the different arrangements, between the quarter, half adjacent, half opposite, and full. And take care that somehow you will find that the half adjacent and the half opposite are almost similar to each other, not exactly the same, but they will be similar to each other. So take that in your notes. Thank you.